All right, the next collection class that we're going to cover here is array lists. Now, array lists are like arrays, but there's a couple of unique features to them. First, they can be dynamically resized as needed. Recall from the previous movie that arrays are set in size once you create them. Array lists aren't like that. Now, the way you create an array list is by using the Arraylist class. And here I've got an array list with a variable named myAL, and I just say new array list. And we'll see how to do this in a bit in the code. You have to include another namespace in order to use these, but the class name is Arraylist. And in this case, I'm just calling the constructor that doesn't take any arguments, but there is a version that does take an argument. I could also just declare this variable by saying new ArrayList and then give it some number, which is the capacity that I want it to start off with. If you don't do this, it starts off with some default capacity, and I don't remember what it is off the top of my head. I think it's like 10 or 50 or something like that. But you can say new array list with 100 or 1,000 if you know you're going to start off with a number that's that large. So to add and remove items from the array list, you use the functions that go along with the ArrayList class. So for example, to add an object to the array list, you would simply call myal.add. And notice that items get added as objects. It takes an object as its argument. But remember, everything in C# is an object. Well, almost everything anyway. Certainly all the primitive data types and any of the classes that you're going to come up with. So you can add objects into your array list. Now you can add, which puts them at the bottom, or you can use the insert method, which takes an object and puts it in at a specific index. And then to remove things, you can use the remove and remove at. So the remove function takes the object that you're passing in as an argument, finds it in the array list, and removes it. Remove at removes the object that is at the index that you pass in. And remember, indexes here are 0 based. There's also an easy way to find out how many things there are in the array list. There's the myal.count, which is a property on the array list, and it tells you how many items are currently in the array list. You can also do indexing with array lists the same way that you would do them with regular arrays. You can do things like myal sub 0. You can even set values this way, which I guess it's okay to do, but my preference is to use the functions that come with the class. Okay, let's take a look at array lists and loops. So suppose we had an array list that we declared like this, and we added a whole bunch of items 1, 2, 3, and 4. Out in memory, this goes ahead and creates an array list with 4 items in it. Now, if we wanted to loop over the contents of this array, there's a couple ways we could do it. We could use the for loop, which we've seen in the past. And in this case, we would have an integer variable named I, and we would loop I up to being less than the count of the items in the array, and we would increment the loop counter. Now, this is a perfectly valid way of doing this. However, there's another way to do this. And of course, we could operate on the contents of the array list. We could write things out. But my preference when working with things like this is to use the for each loop. Now, we didn't talk about this earlier in the course, but I'm going to introduce it now. The for each loop construct loops over all of the elements in a collection. And you can use this with arrays and other things throughout C#. We're going to do it with array lists right here. So for each doesn't take a loop counter. What you do is you declare a variable inside those parentheses. In this case, it's an object because array lists contain objects. So you would say for each object obj in, and then the name of the collection. In this case, it's myal, that's my array list. And then we can go ahead and operate on each object inside the loop. So rather than doing the myal sub I that you see there in the loop, we would change that to console.writeLine and then obj, because obj is going to be set to a different object each time through the loop. That's basically how for each works. It's really nice because there's no loop counters to keep track of. There's no comparisons to make. The for each construct just knows how to loop over all the elements of a collection and put it into an object's variable that you declare here. And well, in this case, it's an object. It can be other things too. But in this case, it's an object because array lists keep track of objects. Array lists can also have mixed content, unlike arrays. So if we declare an array list that looks like this, and then we go and add content to it using the add, remember, each one of these is added as an object. So I've got strings, I've got numbers. I can put anything I want in here as long as it derives from system.object, which all the primitive value types do, and all the reference types that we've talked about, they do as well. So I can do things then like this. I can have an integer variable named result. And once again, I'm going to use my for each construct. And in this case, remember, they're all objects. So for each object in the array list, I can then do something like this. If the object is an integer, remember the is operator from earlier on in the course, I can then say result plus equals, and then I cast or convert the object to an integer by putting the word int in parentheses in front of it. So this is going to loop over each object in the array list, see if it's an integer, and if it is an integer, add it to a running total. So array lists are really nice and flexible. Let's go ahead over to the code and see some of this in real action. Okay, here in the code, I've got my array lists example open, and I've got my example snippets file scroll down to the array lists section, and I'm going to copy these lines right here, and I'm going to paste them into my program, put those in the main. All right, so let's go ahead and take a look at the lines of code and see what they're doing. Here on line 13, I'm declaring a new array list object and putting it into the myAL variable, and then I add some stuff to the array list. I've got a string, an integer, another string, another integer, and then a floating point number. Then I have my for each construct right here on line 20, and I've got my object O variable, and that's going to be set to whatever the current object is each time through the loop. And then I'm checking to see if O is an integer. And if it is an integer, I write out the value of O using the console.writeLine construct. So let's just run this. And you can see that 2 and 4 are being written out. Okay, let's go back and make a quick modification. Let's say for each object, if O is an integer or O is a float, then we'll write it out. And in this case, we'll run it again. You can see that the floating point number as well as the integers are being written out. So array lists are a really nice flexible alternative to using arrays in C#. If you find yourself needing an array construct that is flexible, can contain mixed content, and so on, consider using array lists rather than just fixed-sized arrays.